Now, extinction is a different kind of death. It's bigger. We didn't really realize that until 1914 when the last passenger pigeon, a female named Martha, died at the Cincinnati Zoo. This had been the most abundant bird in the world. It had been in North America for 6 million years, so it wasn't here at all. Flocks that were a mile wide and 400 miles long used to darken the sun. Aldo Leopold said this was a biological storm, a feathered tempest. And indeed, it was a keystone species that enriched the entire eastern deciduous forest, from the Mississippi to the Atlantic, from Canada down to the Gulf. But it went from 5 billion birds to 0 in just a couple decades. What happened? Well, commercial hunting happened. These birds were hunted for meat that was sold by the ton. And it was easy to do because when those big flocks came down to the ground, they were so dense that hundreds of hunters and netters could show up and slaughter them by the tens of thousands. It was the cheapest source of protein in America. By the end of the century, there was nothing left but these beautiful skins in museum specimen drawers. There's an upside to the story. This made people realize that the same thing was about to happen to the American bison. And so these birds saved the buffaloes. But a lot of other animals weren't saved. The Carolina parakeet was a parrot that lit up backyards everywhere. It was hunted to death for its feathers. There's a bird that people liked on the East Coast called the heath hen. It was loved. They tried to protect it. It died anyway. A local newspaper spelled out, there's no survivor, there's no future, there's no life to be recreated in this form ever again. There's a sense of deep tragedy that goes with these things. And it happened to lots of birds that people loved. It happened to lots of mammals. Another keystone species is a famous animal called the European oryx. There's sort of a movie made about it recently. And the oryx was like the bison. This was an animal that basically kept the forest mixed with grasslands across the entire Europe and Asian continent, from Spain to Korea. The documentation on this animal goes back to the Lascaux cave paintings. The extinctions still go on. There's an ibex in Spain called the bucardo, went extinct in 2000. There was a marvelous animal, a marsupial wolf, called the thylacine in Tasmania, south of Australia, called the Tasmanian tiger. It was hunted until there were just a few left to die in zoos. A little bit of film was shot. Sorrow, anger, mourning. Don't mourn, organize. What if you found out that using the DNA in museum specimens and fossils, maybe up to 200,000 years old, could be used to bring species back? What would you do? Where would you start? Well, you start by finding out if the biotech is really there. I started with my wife, Ryan Phelan, who ran a biotech business called DNA Direct. And through her, one of her colleagues, George Church, one of the leading genetic engineers, who turned out to be also obsessed with passenger pigeons, and a lot of confidence that methodologies he was working on might actually do the deed. So he and Ryan organized and hosted a meeting at the Wyss Institute in Harvard, bringing together specialists in passenger pigeons, conservation ornithologists, bioethicists. And fortunately, passenger pigeon DNA had already been sequenced by a molecular biologist named Beth Shapiro. All she needed from those specimens at the Smithsonian was a little bit of toe pad tissue. Because down in there is what is called ancient DNA. It's DNA which is pretty badly fragmented, but with good techniques now, you can basically reassemble the whole genome. Then the question is, can you reassemble with that genome the whole bird? George Church thinks you can. So in his book, Regenesis, which I recommend, he has a chapter on the science of bringing back extinct species. And he has a machine called the multiplex automated genome engineering machine. It's kind of like an evolution machine. You try combinations of genes that you write at the cell level and then in organs on a chip, and the ones that win that you can then put into a living organism, and it'll work. The precision of this, one of George's famous unreadable slides, nevertheless points out that there's a level of precision here right down to the individual base pair. Passenger pigeon has 1.3 billion base pairs in its genome. So what you're getting is the capability now of replacing one gene with another variation of that gene. It's called an allele. Well, that's what happens